Hi again, another video on logarithms. Recall that if you have log of, say, base x of a plus a log of the same base of b, you can say that this is log base x a times b. If you have log base x a minus log base x b, you can simplify this to log base x a divided by b. I now want you to consider this problem here. We have log base 10 x plus log base 10, 13 minus 3x is equal to 1. We need to solve for x. We can use this rule here. So log base x a plus log base x b is equal to log base x a times b. So applying that rule here, we get log base 10. This could be a, and this could be b. So log base 10 x times 13 minus 3x is equal to 1. We want to remove the log by taking the base across the equal sign and pushing the 1 up. You end up with x times 13 minus 3x is equal to 10. Distributing this, you get 13x minus 3x is equal to 10. 10x is 10 and x is equal to 1. Let's go ahead and check our work. If you plug 1 in here, on our calculator we get log base 10 of 1 is 0. If you plug 1 in here, 13 minus 3 is 10, and log base 10 of 10 is 1, and you indeed get a 1. I want us to consider this problem here. Natural log ln of 6x minus ln of x plus 1 is equal to ln of 4. Time to introduce another rule here. If you have a number raised to the power log and the base is the same as this number, then the answer is b. So a raised to the power log base ab is simply equal to b. So if you have e raised to the power log base e, b, the answer is simply b. If you have e raised to the power ln, which is same as log base e, 6x, the answer is simply 6x. So this is also a very powerful rule. Going back to our original rule, we've learned here that log base x a minus log base x b is equal to log base x a divided by b. So let's get back to our problem and rewrite this problem as log of 6x log base e, or ln, is 6x divided by x plus 1 is equal to ln 4. Now, if we consider this, if we try and bring in e to the power, let's say bring in e to the power on both sides, I hope you can see that we have a situation like this. E to the power ln 6x is 6x. E to the power ln 6x over x plus 1 is simply 6x over x plus 1. And similarly, e to the power ln 4 is simply 4. So we now have a simple algebraic equation. Multiplying both sides by x plus 1, we get 6x is equal to 4x plus 4. We can solve for x, and x is equal to 2. I want us to look at this question here now. E to the power 2 minus x is equal to 12. And our task is to solve for x. Once again, we have to utilize our logarithmic rules. And this time, we want to ln on both sides, because the rule can also say that as long as the base is the same, I will rewrite the rule here, log base a to the power b is equal to b, and a raised to the log of ab is also equal to b. So that's the rule we want to use. So ln on both sides will give us an opportunity to bring this 2 minus x down, and of course on the right hand side we have the ln 12. So we get 2 minus x is equal to ln 12. To solve for x, we have 2 minus ln 12, and the answer is negative 0.48. Let's go ahead and look at another question here. And this one says 5 raised to the power x plus 2 is equal to 2 raised to the power 2x minus 1. Again, we have to pick the same base. In this case, let's try and get rid of the 5 by picking log base 5. And you want to log base 5 on both sides. And that brings the left-hand side down to x plus 2. Now, because we have log base 5, we learned another rule that this exponent will come back down in front, which is what happened here. So we end up with 2x minus 1 times log base 5 2. Change of base formula tells you that it is log 2 divided by log 5. We can use our calculator to figure out log 2 over log 5. Distributing it, collecting your like terms, and solving it gives you x equals negative 17. We should check our work. If we think x is equal to negative 17, then if you plug negative 17 here and figure this number out in our calculator, and if you plug negative 17 here and figure the number out in the calculator, they should both be the same, and indeed it is. So we know that x is indeed equal to negative 17. How about this one here? ln x plus ln x cubed is equal to 12. We want to use our rule first to simplify the plus, which turns into a multiplication. Since both the bases are equal, we can put down ln here. ln x times x cubed is equal to 12. That brings the problem down to ln x to the 4 is equal to 12. Remember what ln is. It's basically log base e. X to the 4 is equal to 12. We can turn the logarithmic form into the exponential form by taking the e across, and we have x to the power 4 is equal to e to the 12. To solve for x, we need to raise both sides by a quarter, and we have x, 4 times a quarter is 1, so x to the power 1 is equal to a quarter of 12, which is e cubed. And you can leave your answer as e cubed if it's asking for exact form. Okay, I now want you to pause the video and try these 3 problems on your own. And when you're done, run the video and see if you got it. Let's go through these now. Let's look at the first one. The question was ln 5x is equal to 13. So if you think of ln as log base e, you can turn it into exponential form by taking the base across the equal sign and pushing the 16 up, and you have 5x is equal to e to the power 16. And you can simply solve for x by saying e to the power 16 over 5. I have left the answer in exact form. If you need it in the decimal form, you can plug it in your calculator and get the answer. Okay, are you ready for the next one? Here you have 3 ln x is equal to 13, and of course you want to divide by 3 on both sides and get 13 over 3. Again, changing the ln into log base e, x equals 13 over 3, you can take the base across the equal sign and push the whole fraction up, and you get x is equal to e to the power 13 over 3. And finally, this problem here. Log base 10 of 2x plus 7 is equal to a quarter. Do the same thing. Take the 10 across the equal sign, push the quarter up, and you have 10 to the power quarter, which is basically 4th root of 10. So you have 2x plus 7 is equal to 4th root of 10. So x is equal to 4th root of 10 minus 7 divided by 2. And you can plug this in the calculator and get it in the decimal form. Okay, again, I'd like you to pause your video and try this one last problem, and that will be it for this video. Okay, the answer is x equals 3. So laws of exponents here tell you to keep the base and you combine the exponents, so you get e to the 7x is equal to e to the 21. Since the bases are equal, you know that 7x is equal to 21 and x is equal to 3. Very good. This ends this video. Thank you very much for listening. I'll see you again. Goodbye.